Hey, Myers Mathematics, Mr. Kyle here, and let's just jump right into it. So, 5 reasons why proofs can be really easy. So, before we jump into the 5 reasons, which is actually a play on words, and you'll see what I mean in a second here. Let's go ahead and start with an example and use that as kind of my reason for why these can be really easy. And when I'm talking about proofs, I'm talking about two-column proofs here because this is meant for geometry. So if you're working on higher level proofs, then this video is not going to be for you. In a future episode, I will work on other types of proofs. But for this one, the most basic type of proof is a two-column proof. So let's do that one. So let's look at an example. All right. So for an example, let's prove what's called the vertical angles theorem. Vertical angles theorem. Okay, and it looks something like this. It's got, and I'll use red for my illustration here. Let's say we have these 4 angles, 1, 2, 3, and 4. So basically vertical angles, to go ahead and define them here, are angles that are, and I'm not going to use a technical definition, angles that are across from each other. Okay, so in this case, 1 and 3 are vertical angles, and 2 and 4 are also vertical angles. We don't need to prove both in this little diagram here in order to show that vertical angles really do exist. We only need to prove one. So given, let's start with our givens. So given, this diagram, so basically that angle 1 and 2 are a linear pair. Okay. And then of course 2 and 3, angle, put little angle marks on here, angle 2 and 3 are also. Okay. And then of course angle 3 and angle 4 are a linear pair, and angle 1 and angle 4, but we don't really need to say that in order to prove this. All we need to say is that 1 and 2 and 2 and 3, angle 2 and angle 3 are also. Forgot to include that in there. So angle 1 and angle 2, angle 2 and angle 3 are a linear pair, and of course I'm going to get into that as well. Part of what makes geometry hard is that there's a lot of technical language. So this would be a good class to just kind of bite the bullet and just if you aren't familiar with the vocab, just kind of get into okay, hey, like I need to know what vertical angles are. I need to know what a linear pair is. You just got to know the vocab in order to do well. You just do. It's just kind of one of those things. So let's get into all that as well. So given, and then of course let's go into the prove. So prove. We want to prove that angle 1 is congruent to angle 3, and that's how you would read that mathematically. Again, more vocab. You just got to know what this symbol means. So for instance, like if you're a fan of 3x5 cards, what you could do here is you could say, on the front of your 3x5 card, you could say, you just put the little symbol, and then, you flip it around, and then on the back of your 3x5 with, all the lines, you would put how it reads, right? So angle 1 is congruent. I'm gonna squeeze that in there. Congruent to angle 3. Right? And you could just do that for like a simple 3x5, or if you wanted to go to like Quizlet or Study Blue or any website that has online flashcards, you could do it that way as well. Just again, knowing your math terms is going to be so helpful, because if you see a math problem and you don't know what half the words mean, it's going to be really hard to solve it. So as much as I hate to be a proponent of memorizing things, it is important to know what words mean. And that's something that is important in any discipline. So especially in math, where it's already hard enough sometimes. So let's go ahead and dive into the statements and reasons here. So statement. I'm going to put an S here. Sometimes people like to put statement singular, sometimes plural. It really doesn't matter, just semantics. Statements and reasons. All right, so again, I put that S in parentheses there. So the first thing you always want to do, so here's what I'm going to get to, and I'm going to leave myself some space here, and I'm going to start putting some notes at the bottom here. So the first thing that's really important that I want to say is, at least for the case of high school geometry, you can pretty much bet on the first thing you want to say to be the given. Okay, so the first statement is the given, and the reason is also, quote, given, right? Given is a sufficient thing to say. You can say for a reason given. Okay, and that seems like kind of technical, and it's just because I say things a little technical sometimes, but it's important because there's really only 5 reasons, and that kind of alludes to the reason why I named this the 5 reasons why, because there's only 5 different kinds of reasons that you actually run into. So let's go ahead and start proving our thing here. So angle 1 and angle 2 are a linear pair. Okay, so reason given. And then of course we can say angle 2, I meant to say 2 there, not 3. Angle 2 and angle 3 are a linear pair. And by the way, the little 2 tick marks things, it just means like, hey, I'm going to repeat the word from above. It's like, ditto. You ever use the phrase ditto? When somebody says something and you're like, oh, ditto, me too. Or, true dat, or, whatever. Same, that sort of thing. So basically we're just repeating what's above. So angle 2 and angle 3 are a linear pair, reason also given. Right, so I'm repeating that reason from above there. So there's our 2 lines so far, and I kind of want to have a nice line going on here. Okay, so now let's dive into the actual proof. So once you've done your first thing, first statement is the given, and the reason is also given. So then next we need a plan. So now we need a plan. Okay. So and some proofs are harder than others, right? Granted, some proofs are going to be difficult because proofs can be really difficult. Mathematicians, right? The people that make grand statements about the universe, like Einstein and stuff like that. They do proofs themselves, and so proofs are actually potentially really hard things to do, and to prove something is potentially really difficult. Or it can be fairly simple, like in this case of the vertical angles theorem. But actually, in my PDF that I hand out for free that you can get from my website, the 5 math mistakes everyone makes and how to avoid them, which you should go and get. My third reason why people miss math mistakes is not understanding where to start. Okay, and that's kind of what step 2 is. It's okay, we need a plan. Okay, instead of just kind of diving in, we need a plan. So we need a plan, and what we need to do, we need a plan. We need to use what I call in the PDF, I use tools. We need to use our tools, meaning like, what do you know about geometry so far? What do you know about geometry that we can use here? So if you know what a linear pair is, hint, you should know what a linear pair is. If you're in geometry, you just have to. I get it. It's dumb, and maybe you just, after you're done with geometry, you can just forget all this, right? Just a bad dream. But for right now, if you're in geometry, you do have to know what that is. And it's actually not that difficult. Linear sounds like, yeah, line. And then pair is 2, right? A pair is 2 things. So it's 2 things on a line. That's all a linear pair is. So 1 and 2 are a linear pair. So let's look at this. So 1 and 2, here's the line. Here's 1 and 2. They're on a line. So that means that they are supplementary. Okay, so that would be the next thing that we would say is that they're supplementary. Um, and if they're supplementary, they add up to 180. Well, if 1 and 2 add up to 180 and 2 and 3 add up to 180, well, then that means that they're equal to each other. And then, of course, that means that 1 and 3 have to be the same thing. Now, if you didn't follow all of that, it's okay because we're going to get to that in a second. But our plan is to use the tools that we have. So the tools that we came up with were we know that linear pairs add to 180. Okay, if two angles are on a line, then it has to add up to 180 degrees because an angle that's on a line is going to be a 180-degree angle. That's why it's called a straight angle. Okay, so then we're going to go for it, right? So step 3 is just to go for it. Go for it, right? So just start diving in. Once you have a plan in place, then just go for it, right? Just dive in and see what you can do, and remember to keep the end in mind, okay? So you always want to keep the end in mind. We want to end with angle 1 is congruent to angle 3. That's where we want to end with. So let's go ahead and say our next things. So technically there's you might be quick to say, okay, 1 and 2 are 180 and 2 and 3 add up to 180. The other thing that's very annoying about geometry, and I'll admit it, is that it's very tedious, meaning you have to have all the nice little in-between steps in here. So the next thing we actually want to say then is that angle 1 and angle 2 are supplementary. Supplementary. And then of course angle 2 and angle 3 are supplementary as well. And then the reason. Okay, so I already told you that there's only 5 different kinds of reasons. In this proof, we're only going to need to use 2 that I can remember in order to solve this, besides Gibbon. So we're gonna have some properties and some definitions. This is a definition. So the definition of a linear pair is basically that you have a pair of angles that are supplementary. So angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. That is by the definition of a linear pair. All right. So by definition, if I have a linear pair, then they are supplementary. Okay. So then the next thing I want to say then, now that I know that they're supplementary, I can say this. I can say measure of angle 1. And this is why it's so tedious. A lot of technical language, but you just gotta go with it. Measure of angle 1 plus measure of angle 2 equals 180. And then of course, let's go ahead and say the next thing too. And measure of angle 2 plus measure of angle 3, also 180. There's some degree markers on there. Excuse me. So now, if we look at this, we can say this is by the definition of supplementary angles. Okay, and then of course same thing here. Definition of supplementary angles. All right, so now we've gotten there. And let's just pause for a second and just keep the end in mind here. So so far we've said that 1 and 2 add up to 180, 2 and 3 add up to 180. Okay, well now what? Well, at some point we need to merge my two things that I'm saying here. So if they're both equal to 180, then what can we do next? I want you to maybe think about it for a second. Pause the video if you need to. So a couple things that we can look at here. There's 2 angle 2s. There's 2 angle 2s and there's 2 180s. Well, the two angle 2's are being added to measure of angle 1 and measure of angle 3, which we know are going to be equal, right? Because that's what we're trying to prove, but we can't assume it yet. Otherwise, we'd kind of be going in a circle. We have to, assume what we're trying to prove in order to prove the thing we're proving. Excuse me. A little bit of that case of hiccups. So we do know that 180 is equal to 180, right? That's obvious, right? 1 equals 1, 2 equals 2, 180 equals 180. So we can say then that the measure of angle 1 plus the measure of angle 2 equals 180, which is also equal to measure of angle 2 plus measure of angle 3. Now we've merged our two different statements that we've been making. Okay, and there's a couple different things you can say for the given here, or sorry, for the reason. I would probably go with substitution property. Substitution property. Okay. Um, and the reason why I would go with substitution property here is because you could also technically say transitive property. And again, if you don't know what these are, I would suggest looking them up in the book to make sure you have the right proper technical language. But basically, substitution property is saying, hey, there's this thing here, and I'm putting something else that's equal to it in its place. That's all substitution property is saying. However, transitive property, trans, that prefix, also being used for like translate, if you want to translate from English to Spanish, or transcontinental, that sort of thing. It means to move, like to go from one thing to another. So the transitive property is basically like, hey, I have this thing that equals this thing, right? So in this case, measure of angle 1 plus measure of angle 2 equals 180. And then I also know that 180 equals measure of angle 2 plus measure of angle 3. So therefore, if A equals B and B equals C, then A equals C. That's the whole transitive property. You're basically saying, okay, if one thing goes to this and then that, this thing goes to this other thing, then I can just skip the middleman and go straight from A to C. Okay, so again, if that sounded a little bit overly technical, it's because that's kind of the name of the game, and that's why I stick with substitution property. Because if it is transitive, you can say substitution, and that's just fine. But if it's substitution property, you cannot say transitive all the time, because sometimes when you substitute, it's not also transitive. It doesn't work both ways. So in order to stay safe, I would avoid using transitive property and just use substitution property. Okay, my humble opinion there. So substitution property, and so far we've only used, well, actually we've used 3 different kinds of reasons so far. We've got given, 2 givens, 4 definitions so far, and then a property. Okay, so there's actually 3 so far types of reasons that we've used, and there's only 2 other kinds of reasons that you can use, and we'll get into those in a second. But now the next thing I want to do, and it's normally not the usual thing to do to like actually show the math in the proof, but I want you to see what's going on here. So if you're not sure what to do next, somehow that these two cancel, maybe. Okay, maybe you were thinking about it already, maybe you weren't, and you were like, oh, true, why though? Well, the measure of angle 2 is a number, right? So if you can kind of think about it here, like if you look at the picture, measure of angle 1 looks like maybe, I don't know, 45 degrees, something like that. So if this is 45, and I'll erase this in a second, but let's just say this is like 45, and then that would make that 135 equals 135, right? It'd have to be the same thing plus whatever measure of angle 3 is, right? So let's just say we don't know what it is. So I don't know, let's call it x. Well, if I know for sure that the measure of angle 2 is 135 degrees, in math, what we would say is, well, for one, you would add 45 and 135, but also, couldn't I subtract the 135 from both sides? Right, and then the 135s would go away from both sides, and I would know that x equals 45 degrees. Okay, and that's exactly what I'm doing here. I'm subtracting, right? Keyword subtracting. I'm subtracting the measure of angle 2 from both sides. That's what's happening there. So basically measure of angle 2, measure of angle 2, subtract, subtract, and then I have here, second to last thing we're going to say. So I'm going to subtract. If I'm subtracting, anytime you do any algebra, you add, subtract, multiply, divide, etc., something from both sides, right? That's called solving. Okay, and I don't know if I've already put out a video on this actually, but there's a way I like to do solving called SAD-MEP, which is basically PEMDAS spelled backwards. And in there you can see, okay, there's a clear difference between when you're simplifying, when you're just adding something, adding 2 and 3 on one side of the equation, and when you're adding 2 to both sides of the equation. There's a difference, and that's the difference between simplifying and solving. And if that video isn't already out, which I don't remember if I have put out a video on that, then I will definitely put out a video on that because it's just life-changing. If you've ever struggled with solving an equation ever, that is a video that you want to see. So anyways, I subtracted something from both sides. Therefore, what I need to say is subtraction, not substitution, subtraction. Oh my goodness, I cannot spell. Subtraction, property. Okay, so this is a property, and it's not just a property, it's a property of equality, right? And when I taught this, I just told my students, okay, it's called property of equality. You need to know that, but we're going to abbreviate to PO. One, because it's fun to say, and it's a Teletubby, if you remember what that show was. And it's also the name of a ghost in a very favorite game of mine called The Legend of Zelda. So PO, P-O-E. All right, so subtraction PO, property of equality. We did something to both sides, we subtracted, so that's what it's called. If I had added to both sides, right, you guessed it, addition, property of equality. So this is actually not where we stop though, because measure of angle 1 equals measure of angle 3, you're right, is basically the same thing as saying angle 1 is congruent to angle 3, but it's not exactly the same in geometry. It's all about being exact, and it's annoying and frustrating, I know, but you just got to do it. You just got to bear with me here. We have one more thing we have to say. So angle 1 is congruent to angle 3. Okay. Now we can say that immediately after angle 1 is equal to angle 3 there, because of the definition of congruent angles. Okay. By the definition of congruent angles, I know that angle 1 is equal, or sorry, angle 1 is congruent to angle 3 because the measure of angle 1 is equal to the measure of angle 3. Whew. All right, there we go. So I've already got a couple things that I've said on here. Now I want to say something else that's really important. Okay, and this gets into the 5 reasons why. So the 5 reasons. We've got 5 kinds of reasons. Okay, and this is really helpful for you because this narrows down your list of choices. It seems like there's a million different reasons that you could potentially put, and there's a lot, but there's only 5 kinds of reasons. And here's the deal, right? We already said what we need to say about given, right? Given is the first thing you say. After you're done saying everything that's given, you don't use given anymore. Okay? So 1, given. Okay, this one's really awesome, right? This one's once it's used up, once used up, and I mean used up by after you've stated all the givens that are in the problem. So in our case, we had 2 givens, and I just stated them both up front to get them out of the way. Okay, so once used up, then you're done. Then you're done. Meaning, once you've said all your givens and you've said the reason is given, you don't need to use that one anymore. So really, there's only 4 after that. Okay, and here's the other one, definitions. definition. Okay, so this is the part where you have to just know. Okay, hey, a linear pair is, well, what is a linear pair? It's a pair of angles that are supplementary. You have to know the exact definition. That's why this gets a little annoying, because definitions are annoying. But they're very, very useful, very helpful, just in real life and in everyday life. If you don't know what a word means and you try to use it in an argument against somebody, all they have to do is say, well, no, that's so for instance, let's say you were trying to say that some cats don't have any fur, right? Like furless cats, you know what I'm talking about, like Siamese cats and stuff like that. Well, um, you could say, like, they're pretty much devoid of fur, blah blah blah. But if you think about it, um, cats are defined as mammals, and all mammals have fur. Even the aquatic, right? So even like dolphins, they have a little bit of fur around their blowhole. Um, so or I should say hair, maybe. It's a scientific semantic. So I'm delving a little bit into a realm that I'm not as familiar with. But nonetheless, so the point is, if you're trying to tell somebody that the Siamese cat doesn't actually have any fur, you can be like, well, no, maybe it doesn't have very much fur, but it's got to have some fur, or some traces of fur, or whatever, because it's a mammal. That cat's a mammal, and therefore it has to have fur, right? So anytime you're trying to win an argument with somebody, knowing the actual definition of something is extremely helpful. Okay, so definitions are one of your kinds of reasons. So if you know the definition, then you just say exactly what the definition in your statement. So definition of blank is X, Y, and Z, right? So the X, Y, and Z would be your statement, and the reason is definition of blank. Okay, so these are hard, but they're straightforward. But they're straightforward. Okay, hard but straightforward. Meaning you know it. If you know it, then you just say it. That's it. You just know it and then you say it. Okay? Then we get into kind of the meat of high school geometry. Lots of properties. Okay? Lots of properties. Right? So then we have properties. And these are a little bit more ambiguous. They're just not as clear. You're just like, okay, just property just means it's like a thing that happens, right? So it's not a definition, and it's not the other two that I'm about to mention here in a second. But oh, excuse me. So it's not any of those things. But so if I have, let's say, substitution property, it just means that I can substitute things. It's a property of geometry, of mathematics. So this is like the meat. This is the meat of geometry. It's again, you just have to know it. You'd have to know what your properties are, just like your definitions, and then you can state them. But a property is not a definition. They're two different things. Definition is just a straight fact, whereas a property is like, hey, there's this thing in math where you can do this thing, and that's kind of what a property ends up being. So the other two, real quickly before my laptop dies on me, um, are postulates, which are sometimes called axioms, right? So again, this is for high school geometry. In later editions of mathematics, you stop calling things postulates so much as axioms. And there's a difference, but it's kind of semantics. It's kind of just, um, you know, six one half dozen of the other kind of thing. But essentially, a postulate is something you assume. So it's assume, you assume, and it's obvious. It's obvious. Okay, so something that's really obvious, like 2 + 2 = 4, right? That's a postulate. Okay, and you can't prove, so it's not proved, right? So you might be like, well, I can prove 2 + 2 = 4. That's where math gets hard. Is is something that's really, really obvious actually sometimes can't be proved because everything else is proved based on the really obvious thing. So you have to start somewhere, right? With anything, you have to start somewhere. You have to assume some things to be really, really obvious and then go from there. And there's actually five main postulates or axioms of of geometry that um, the geometry that you learn in high school is based around. But that's another story for another time. The last thing is the theorems. And actually, we just proved one. We proved the vertical angles theorem. So that just means it can be proved, right? So can be proved. So it's kind of the opposite of a postulate in a sense. And again, this is theorems are just extra things. They're kind of in the same field as like properties and definitions. You just kind of have to know them once you prove them. But usually with the more simpler ones, like the vertical angles theorem, you do actually talk about them in class. Say like, hey, this has been proved. Now let's use this in future proofs, so we don't have to waste our time proving it all over again. Okay. So those are the five different kinds of reasons. And again, these are simple reasons in geometry, high school geometry. There's other different things like lemmas that are talked about later on in mathematics. So, if anybody is watching this and they're, a math major, don't get too crazy at me in the comments. All right, so that is it for this video. This has been Mr. Kyle and Myers Mathematics. And hey, so I've noticed a few more subscribers here and there on my website. I'm working on getting my emails automated and that whole process. So if you're waiting on your PDF for the five reasons, the five math mistakes everyone makes and how to avoid them, I'm working on automating that process, and so there's a little bit of a delay there. We can definitely expect that to be working in the new year as we get past the holiday season here. All right, so have a great one. And if this video has been helpful, of course, give it a like if you like this channel a lot, then he'll go ahead and smash that subscribe button, and I'll see you very soon.